Dear students, in this video we will see how to solve this problem. The given problem is a cylindrical roller of diameter 1 meter, and the weight 10 Newton is being pulled by a force F. The force is given in the diagram, 30 degree, which acts 30 degree to horizontal as shown in figure. Right? Calculate the force required by the roller to cross the obstacle. See, there is an obstacle given which height is about 10 centimeter. The roller is pulled by the force to cross the obstacle. While crossing the obstacle, see, the roller is rotating in clockwise. So while crossing the obstacle, it will give all its weight towards this obstacle. Pushes the obstacle with the total weight and then it crosses. So that is the logic behind it. Now we will proceed the problem. You go as usual by the first step. Draw the forces in the figure. So first force is weight. It acts downwards. Then two places reaction. I have mentioned it as R1 and R2. And this fourth one is external force, F. So if you draw the free body diagram by keeping the R1, move the R1 along the line and keep it here. Similarly, move the R2 along this line of action of R2 and keep it here. So the free body diagram will come like this with the four forces. The force R1 and W acts on the vertical axis. The force F inclined 30 degree is given. But the R2, which is inclined, we did not know the angle. So first we have to find the angle. For finding the angle, always try to find a right angle triangle and by keeping that force, that line, as one side. So if you this point, if you draw in a horizontal from this point towards left and draw in vertical towards the center and connect this, a triangle will come, right angle triangle will come. Now try to find the two data of the triangle, mostly two sides of the triangle, so that you can use that in sine law and find the angle. So now if you see this side, the hypotenuse side of the triangle falls on the radius of the roller. Am I right? It is equal to the radius of the roller. So the diameter is given 1 meter. So the radius will be 0.5 meter, which is 50 centimeter. Here it is given in centimeter, so I took as centimeter. 50 centimeter is the hypotenuse length. Now come here, this side, from the center point to this point. The distance is equal to the radius, 50 centimeter. In here, the triangle side is having a small reduction, this much. See this, it is equal to the height of the given obstacle, which is 10 centimeter. So totally 50 minus 10 will give you the side, this side as 40. So two sides we know. You can find the angle of this point, this side. By using 40 is the opposite side. For this angle, 40 is the opposite side, 50 is hypotenuse. So you can use sine theta equal to 40 by 50, that relation. If you want to find this angle, you can also do. You can find also this angle. This will come with cos 40 by 50. So don't confuse with this. Already this right angle triangle relation was discussed in previous class. So this 53 is the angle made by this line, the line of action of R2 with the horizontal. Okay, so it will come here. 53 will come here. If you found the angle here, okay, if you found the angle here between the R2 line and the vertical, then the angle will come here. Okay, I will mark. So if you found the angle of this point, then here you have to mark. Then now see, there is a note for this particular problem. Already in the starting I told, when the roller is crossing the obstacle, it gives all its weight towards the obstacle point. Hence the total reaction force, it is given as resistance. Total reaction force will be given by the obstacle only. By the floor at R1, there will be no reaction force. Okay, there is a logic behind this problem. So you can take this R1 as 0. So if you took R1 as 0, this R1 force will not exist. So now if you see how many forces are there, there is 3 forces. You can solve by either Lami's theorem or by equations of equilibrium. Here I am going to solve by using Lami's theorem. So for solving Lami's theorem, you should know the angle between two forces. So let us calculate that first. So angle between R2 line and W is 90 plus 53, 143. And this side, angle between F and W is 90 plus 30, 120. Then the angle between R2 and F is, you can do 180 minus this 53 minus this 30. So it will come 97. So after finding this, fit the data in the sine law and Lami's theorem. Okay. So you can do R2 divided by R2 is here. What are the 3 forces? R2, F and W. R2 divided by sine 120. F divided by sine 143. And W divided by sine 97 will come, which I have written here. Okay. Now select the first 2 and we can find the F value. So sine 143 will go to this place. Okay, as like this. 1000 is the value of W. So W into sine 143 divided by sine 197 gives the answer for force F is 606.33. Okay. Similarly, we can take the next 2. Next 2 equations. Now for finding R2. So sine 120 will go here. Okay, as like this. So 1000 into sine 120 divided by sine 97 is 872.53 is the answer. So this is the method of solving such a problem.